We are heading to Costa Rica. Earlier, we were in Costa Rica with Andy Whitworth and Eleanor Flatt from Osa Conservation. We were hanging out in the treetops. Now we're going to get down onto the ground because the world depends on healthy rainforests for everything from clean drinking water to fresh air to economic development. So regrowing the rainforest where it's been cut down is a complicated task. Hilary Brumberg, the Lowlands Ridge to Reef Program Manager, and María José Mata, the Restoration Rewilding Program Coordinator, are going to be joining us at the site where they trial restoration and rewilding efforts to recreate missing pieces of rainforest ecosystems. So here we go. There they are. Hilary, María José, how are you?
Hi, Joe. How are you?
Good, good. Good to see you.
Good to see you again. Thanks for having us again.
Of course. Happy Biodiversity Day. It's a big day today.
Yay. Thank you. You too.
Must be pretty nice to spend Biodiversity Day somewhere that has 2.5% of the planet's biodiversity in a pretty small spot.
Absolutely. Yeah. For us, every day is Biodiversity Day.
Very cool. Well, look, I'm going to let you take over for a bit. I've seen this a few times and it's amazing. The work you're doing, it's very exciting. So I can't wait to share it with the world.
Thank you, Joe. So as Joe said, my name is Hilary Brumberg, and I am the Lowlands Ridge to Reef Program Manager here at Osa Conservation.
And I'm María José Mata, and I coordinate the Restoration and Rewilding program here at Osa Conservation.
So Osa Conservation is a grassroots nonprofit organization dedicated to conserving the incredible biodiversity of the Osa Peninsula in Costa Rica. You saw some of the presentations from our coworkers Andy Whitworth and Eleanor Flatt earlier today. And now we're going to continue sharing with you some of the incredible work that we're privileged to do here at Osa Conservation. Right now, María José and I are going to show you a really exciting restoration and rewilding experiment, and also our brand new Osa Arboretum, which is one of the largest botanical arboretums in Central America, which is focused on conserving tree biodiversity in Costa Rica. We particularly focus on conserving endemic, endangered, and rare trees. So throughout our walk today, you're going to see a number of interpretive signs and also these little signs with QR codes that link visitors to the Osa Arboretum to our new Arboretum website, osaarboretum.org. So if you're following along from home and want to check out the incredible plant biodiversity of the Osa Peninsula, feel free to check out osaarboretum.org, and you can explore the Osa Arboretum virtually as well.
So we're here in southern Costa Rica, and you've probably heard about Costa Rica because it's important biodiversity, and also a lot of conservation we've done here throughout the years. And a lot of deforestation happened in Costa Rica a few decades ago, but luckily we have some great legislation that has been improving the whole ecosystems throughout the country. And we have a payment for ecosystem services, and a lot of different efforts that can help us now. Well, it helped increase the forest cover, so we have a lot of forest, but now we can focus on creating connectivity between those patches. So we're going to tell you a little bit about how we are trying to improve that connectivity.
Exactly. So as María José said, we are working to restore areas of the rainforest that have been degraded. And this is especially important here in Costa Rica, but across the world. Recently, ecological restoration has gained a lot more traction publicly, as it is a natural climate solution. And additionally, it is really important for recuperating biodiversity that has been lost due to deforestation and agricultural development. However, ecological restoration can be very expensive and very time consuming. So part of María José and my job is to develop techniques to make restoration more time efficient and more economically efficient as well.
And the reason, because it is not always as cost efficient, is because most efforts have been done in this old paradigm of deforestation, where we just take some seeds or some seedlings from the forest and plant them where we want to regrow a forest, and that's not always an easy task to do. So this old paradigm is planting trees in rows at the most, and you get a lot of mortality when you do that, and you have to invest a lot of in maintenance of those trees. And then on the other hand, doing natural regeneration, which is just leaving the land regenerate itself, but that can take many, many, many decades or not happen at all, depending on how degraded the land is and the conditions of the land around you. So we have to come up with a new paradigm and new ways of doing restoration throughout the world.
I'm so excited to share with you all today our restoration and rewilding experiment here at Osa Conservation. So the land that we're standing on right now was cattle pasture just 4 years ago when I moved to Costa Rica. And it's spectacular to see how much the trees have grown. I'm from Boston, and back home, the trees would not grow this quickly. So it's very rewarding to work in ecological restoration here in Costa Rica and see how our efforts are paying off very quickly to recuperating forest cover and biodiversity. So as Maria Jose said, we developed an experiment for ecological restoration, and we're trying to mimic the natural cycles for forest restoration, forest recovery in nature, but we're trying to speed it up. So what we did is we are focused on planting pioneer trees. So those are usually the first trees that recover in an ecosystem after it's been degraded, either by natural disturbance or human disturbance. And we planted those in different ratios with also slower growing trees in order to determine the effect of planting these faster growing pioneer trees on the recovery of forest structure and biodiversity in the area. So we are currently at the site of some of our restoration plots. In total, we have 40 plots, which are each half a hectare. And we have 4 different treatments with different ratios of this pioneer tree. Here we focus on the balsa, which is a fast-growing tree that you're going to see soon, which is native to the area and has broad leaves. And we planted it in different ratios. So we have some areas where we have 0% balsa trees planted, other areas where we have about a third of the plots are balsa, and in other areas where about 3/4 of the plot was planted with balsa. And then we also have plots that are controls, where we didn't plant anything and are just letting the forest naturally regenerate itself. So that way we can compare the effect of our active restoration treatments with the passive natural restoration of nature. So we can compare how the rainforest recovery is when humans intervene versus the slower natural processes. So where we're standing right now is one of the areas where we didn't plant any balsa. So believe it or not, these are actually the slower growing trees. These were all planted in 2017. And you can see they're maybe 1 story high, if that, depending on the species. And now we're going to show you some of the areas where we planted the faster growing balsa. And bear in mind that all of the trees that you're going to see today, we planted at the same time in 2017. So as we're walking through here, you can see that there's a good number of this tall, nasty grass, which if you walk through in shorts, you'll come out with a bunch of cuts on your legs. So this is one of the most difficult parts of doing ecological restoration, is making sure that when we plant our little saplings, they can outcompete these grasses. So our team of hard workers from the community will come through after we plant the saplings, and we'll cut circles with machetes around each of the baby saplings that we plant in order to help the saplings grow up so they don't have to compete with the weeds. And we do this 4 times a year. And so it's a very, very time-consuming process. And we need to do this for a good 3-4 years for some of the smaller, slower-growing trees. So that's one of the biggest costs and time consumption for the maintenance of our restoration initiative.
These grasses can get even taller than me. So imagine that the hard work it takes. And the trees have to outgrow that grass before they start competing with the grasses.
So now we're walking to one of the plots where we planted 75% of the balsa trees. Oof, I'm already feeling some shade and some nice breeze in here, which is much needed on this hot day in Costa Rica.
Yeah, there are mosquitoes around also. So as you can see, this tiny landscape looks a lot different from where we were just looking at. These are the famous balsa trees. They are pioneer species. They grow super fast. They shed a lot of leaves in a really fast way. And as they do that, the shedding of the leaves, they cover the soil, they regenerate the soils, let me show you this. They bring all of this organic matter, and most importantly, maybe, they kill the grasses and the weeds, so the trees do not have to compete as much with it. And also, it gets a lot cheaper when you don't have to invest as much in tree maintenance.
Exactly.
So the idea is that this can be an efficient way of regenerating forests faster and more efficiently. The idea is not to plant a forest of balsa, but the thing is, these trees can live only from 20 to 30 years, around that. And so as they start to naturally die out, it just simulates the natural regeneration processes that happen already in nature.
Exactly. So by planting these balsa trees, we're not just planting a forest to sequester carbon, but we are planting the food and the habitat for animals to come and build their nests and to munch on the delicious balsa flowers. And while they're in the balsa trees, they will go to the bathroom and disperse seeds of hardwood, slow-growing trees. And those seeds will grow into the forest that will be here long-term for hundreds of years. Mm-hmm. And the wildlife will come in and bring a really large diversity of different types of seeds into the area.
And let me show you some evidence that we have some wildlife bringing some
Yes, please.
You can see this tiny plant. This is a kind of a shrub, a pepper plant. And we have some other trees like this one, for example. These are already coming by themselves, with the help of birds and monkeys also. And it's really exciting because we didn't plant this. And that's basically the goal of what we're trying to do, to accelerate the recuperation of the space.
So now we're continuing walking through our half hectare balsa plot, enjoying this beautiful shade. And one of the other important parts of ecological restoration, in addition to planting trees, is helping facilitate wildlife to come back. So the balsa trees themselves are really important to attract birds and monkeys, but we want to bring back wildlife even faster, so that we're creating a living forest, so that way these animals have habitat to live in and also can disperse seeds for us to continue to regenerate the forest with a really high biodiversity of tree species. So we are incorporating rewilding techniques, which is the idea of bringing back wildlife that were once in this area but left when it was cattle pasture. And so we are kickstarting the natural return of wildlife by adding rewilding elements such as this bird box, which you can see behind me. And this is really important because birds are key pollinators and key seed dispersers, but it can take decades for trees to get large enough to have a hollow cavity in order for birds to lay their nests. But we installed this bird box just a couple years ago, and shortly after, there's already a house wren family that had its nest in there. And so we have evidence of recuperating the return of wildlife to this area. Additionally, in a mature forest, there will be a lot of down logs and tree trunks, which is really important to provide habitat for amphibians and reptiles and insects, and also to maintain soil moisture. But in a young recuperating forest, their trees aren't big enough to have down logs. So we wanted to kickstart the recreation of these microhabitats. And so we created these log piles, which is a very accessible form of rewilding. These are just pieces of wood from our wood shop that we've laid down, and we're monitoring them, and we've already seen that wildlife has returned there. This is a great example of very accessible rewilding techniques that can be replicated anywhere there's some extra logs or extra wood. In addition, we have a few other rewilding elements that we're excited to share with you. Maria Jose, what is this giant box?
This is my house. Now, this is a bathhouse. So the idea is to recreate some of these spaces that wildlife needs. And one of them is those big cavities that you can see in all like 200 years old or more trees. And they host a big diversity of wildlife, and one of them is bats. And they are also important pollinators and seed dispersers and all kinds of ecosystem services providers. And we have a big family of bats living here throughout the more than 20 bat boxes that we have in our experiment.
Can we show these guys?
Yes.
Okay, Maria Jose is just opening the door here, and we're going to pop you inside and see if you can see the family of bats. Do you see that little black speck in the upper left corner? And then the group of black specks that's in the top corner. Those are little families of bats that are all huddled together, occupying our bat box. Okay, we're gonna let them enjoy their rest. Continue with the tour. Bye, guys.
So Hilary, I'm curious about the bat box
and Maria, what are these other trees?
These other plants.
Mm-hmm.
These are other types of rewilding elements that you can also easily add to your reforestation effort. Mm-hmm. And they're very accessible and they're very effective. So we planted banana plants, Panama hat plants, papaya trees, and other flowering plants. And they are super effective because all kinds of birds and medium-sized mammals love them, and they can bring food to a place, and we don't have to wait decades for big trees to have this kind of fruit.
Exactly. That's a summary of our restoration and rewilding experiment. So while we would hypothesize that biodiversity is recuperating in the areas where we've planted trees and installed these rewilding elements, we want to collect hard evidence. So that way we can see which of our techniques are working and which of them aren't working, so they can be scaled up across southern Costa Rica, across the region, and even globally, in order to recuperate biodiversity, sequester carbon, and other ecosystem services. So before we planted these trees in 2017, we took a baseline of the biodiversity in the abandoned cattle pasture. We're monitoring a few key indicator groups that indicate the health of the area. These include birds, bats, dung beetles, amphibians, and butterflies. And every 2 years, our team is going out into the fields and continuing to monitor how the different biodiversity groups respond to the restored forest. And it's really exciting. Just a few years later, we've already seen, in particular, that dung beetle communities have changed. And dung beetles are indicators of larger animals such as mammals. So we're already having indications that wildlife is recuperating in the area with these young trees.
And we've also seen the recuperation of the structure of the land, because we measure the trees every year. We measure a big sample of the trees, and we also monitor the mortality of them. So we go out into the 30 plots that have been planted, and we measure the height, the DBH, and some other variables, so we know exactly how much balsa is helping the other species to have a healthy environment to grow. We also monitor the soils, some changes in the chemistry and the physics of them, because soils can tell us even more about the health of ecosystem and how much it is beginning to look like the forest. And with that, we also monitor the changes in microclimates together in collaboration with the University of Costa Rica. So that fancy equipment you see there monitors temperature, precipitation, and humidity.
Yeah, this is our brand new meteorological station. So in addition to the different monitoring elements that Maria Jose just mentioned, we use a number of other technologies to monitor the recovery of the forest, including drones and acoustic devices. And we are always looking for more ways to monitor the restoration of this area, so that way we can have more evidence for the importance of these restoration techniques. And our goal here is not only to restore these 20 hectares, but to use the lessons learned from the successes in this project to facilitate the restoration of Costa Rica and globally. So a lot of these approaches can be scaled up and replicated in other areas. So for example, you wouldn't necessarily use balsa, but you could use a different pioneer broad-leafed native tree species in a different area to help facilitate the recovery of the forest and shade out those nasty weeds to keep restoration costs down and bring biodiversity back more quickly. So it's a privilege really to get to work every day with such young, passionate scientists, and also to get dedicated lives to conserving and recuperating biodiversity here in the Costa Rican rainforest. If you'd like to come visit us once you're vaccinated, we would love to have you come visit our restoration project, come visit our arboretum and our other incredible conservation projects here at Osa Conservation. You can visit us on our website at osaconservation.org, where you can find out about different opportunities for coming down to volunteer or get involved in other ways.